Hi everyone, so let's jump into our first example of these problems involving our angles of twist and our gear ratios. So what we have right here is two solid 1 3/4 inch diameter steel shafts. And they're connected by the gears shown. One has 54 teeth, the other has 30 teeth. The shaft lengths are 6 feet and 10 feet. We're going to assume that the shear modulus of both shafts is 12,000 KSI. All of our bearings are frictionless. They allow them to turn freely. What do we want to find? Well, we want to find a lot. We want to find the internal torque in sections 1 and 2. We want to know the angles of twist in both sections, the rotation angles in both sections, and the rotation angle of gear D, B, and C. So, I want you to go ahead and pause and try this out. I'm going to give you one little big hint. Gear ratio. That is going to make everything so much simpler. So, don't forget about that. Gear ratio. It's the magic words here. So, pause, try it out, come back, and let me know how you did. So, 3, 2, 1, and let's continue. So first off, you gotta figure out the relationship between torque. So if we look in our first section, we cut it, we're gonna get a torque in that first shaft of 225 pound-foot. There's nothing else there, so obviously if I apply a torque of 225 pound-foot, it's gonna feel a torque of 225 pound-foot. Now, the torque applied to that gear C, I'll go back a little bit so you can see it right here, will also be 225 pound-foot. So that's 225. That's going to be turned with a 225. And it's going to start turning the other one with that amount of torque. And then here's where I'll begin using my gear ratio. This is the gear ratio right here. So if I want to find the torque in gear B, well, it's going to be connected by the difference in the radiuses, or the difference in the number of teeth of both sections. So my gear ratio in this case is 1.8. 1.8. And so my torque will be equal to negative 405 pound-foot. I'll be turning in the opposite direction. And you can see all that from right here. So now that I have that torque applied, and now that I know my gear ratio, I should be able to solve pretty much everything else. So, let's look at our section properties because we're going to need to find out the angle of twist now. So, polar moment of inertia, going to be super helpful for us. This is for section 1. Both of them are going to have the same polar moment of inertia though because they have the same diameter. And then using that, we can find the angle of twists in both shafts. So we put our torque in here, our length, to make sure to convert from feet to inches, and convert from KSI to PSI. We plug it in and we get that section 1 will rotate negative 0.0316 radians, and section 2 will rotate 0.0293 radian. But that's like in a vacuum. Currently, we didn't actually take into account the fact that the gears are connected. The gears are still connected. So, like before, we're going to have this section 1. I'm going to start at A and go to B. I'm going to say that A is 0. That's going to be my origin. And my gear is right here. There we go. Let's add some geariness to it. Perfect. Okay. So I know how much section 1 rotates. It rotates negative 0.03169 radians. And so gear B will also rotate negative 0.03169 radians. But as gear B rotates, it will also rotate gear C. And it's going to rotate in the opposite direction. How much it rotates is going to be dictated by the gear ratio. So I plugged it in there, being very, very careful about how I use my gear ratio. And I'll get that it rotates 0.0570 radians. 0.0570 radians. Then finally, I can get to gear D. So that's going to be looking, starting at gear C, and then going all the way to D. And it's going to change by however much I have twisted in section 2. And so they both turn in the same direction, and so I will add these two. So gear C gets turned by gear B, which gets turned by the torque applied to A, and it all goes down the line until we finally reach gear D. Oh, went too far. So I'm going to jump back real quick just so we can see this physically. Here we go, a little bit further. My goodness, jumping back there. Here we are. So we started at point A because this one does not move. Its rotation angle is 0. Section 1 turned, and then it turned gear B. Gear B is going to turn gear C in the opposite direction. And we know that there's a torque applied in this one, which will cause it to turn even more. So all of that twisting happens. And finally, we can figure out what the rotation angle of D with respect to A is, based on all that. Figure out this twist 1, that gives us twist B. We use our gear ratio to find twist C, and then we do use our twist in section 2 to finally find the angle twist for gear D. So, lots of stuff happening here, but I hope this helps you. I hope it makes sense. If not, we're going to do another example to try to drive it home. So thank you for listening, and I'll see you all next time. Bye-bye.